Hey, hello, and welcome to today's session on gRPC. So, REST APIs are everywhere, but what if you want faster communication, smaller payloads, or real time streaming? That's where gRPC comes in. So, in this video, I'll explain what gRPC is, the comparison between REST and gRPC, and I'll also explain the four RPC styles. Okay, so first of all, let's see the difference between REST APIs and gRPC. So uh, REST generally runs on HTTP 1.1 protocol, whereas gRPC runs on HTTP 2.2 protocol. So what are the benefits which HTTP 2.2 provides over HTTP 1.1? So in HTTP 1.1, the requests sent, the request or the API calls made by the client to the server are sequential in nature. That is, they happen one after the other, okay, in the same connection, okay. Whereas in gRPC, the request can be made parallel, okay, which is called multiplexing in HTTP 2.2. Okay, the calls, the network calls made by the client to the server, okay, in one particular connection, they can be made parallel. Okay, so I'll explain this in the next section in detail. You'll understand better. Okay, so the next difference is generally in REST APIs. In REST APIs, JSON is used in request and response. We have seen, right? So generally we use JSON. Okay, whereas in gRPC we use Protobuf. Now, what is Protobuf? Protobuf is a so in Protobuf, the data is sent in binary format. Okay. Now what is the advantage of binary format? It is compact. It is much more compact than the JSON. For example, if we see, right, this is an example. So this is a sample response in REST, right? This is JSON sample response. Generally, we see JSON, right? So it is human readable, definitely. But what it is taking is this particular response, it is taking 65 bytes. Okay. But if we compare the same thing, right, in Protobuf, so as I said, it's bytes, right? It's binary data. Okay. And it is taking 12 bytes only. Okay, so it is much more compact than JSON. Okay, okay, so taking less space, so taking less network bandwidth, and hence it also makes the communication faster, much faster. Okay, because of the compact nature of the binary data. Okay, so this is one difference. Then the third difference is used for request and response. So generally we have seen, right, in the REST APIs we make a request and then we get a response. Okay, but in gRPC there are four modes. I will say four streaming modes. Okay, so one is the Unary mode. It is like the same request response at REST, right? REST APIs. Okay. The other one is server streaming. Server streaming is the client makes a request to the server, makes a network call, makes an API call to the server, and server returns or responds with multiple responses, So we'll see all these streaming modes in detail. Okay. Then there's client streaming, wherein the client keep on sending a request to the server. Okay, and the server responds and the server returns one combined response. Okay, then we have bidirectional streaming, wherein the client can send multiple requests to the server and the server returns with multiple responses. Okay, so we'll see this in detail. Okay, then in REST APIs, right? So we generally have to implement, we have to write a lot of boilerplate code. You have to create basically the DTOs, right? The request response DTOs and all. Okay, but in case of gRPC, right, the stubs are generated by the proto compiler. That is, the DTOs are generated by the proto compiler themselves. Okay, looking at the proto file. So you have to define a proto file, and when you run the proto compiler, the all these DTOs and all, they are generated. So we'll also see these in detail. Okay, so let's come to the next section, wherein we'll see the difference between the HTTP 1.1 and HTTP 2.2. Okay, so generally in case of REST, right, wherein it runs on HTTP 1.1. So as I said, right, there's a client and there's a server. So the REST APIs are hosted on this server. Okay. Now the client wants to call the APIs of the server, right? Wants to call the REST APIs for the server. So what generally happens is when you first make a request from client to the server, a TCP connection is made first. Okay, between the client and server. So once the TCP connection is established, so so the we make a REST API call, right? So let's say that R1 is that particular REST API call. Okay. So what happens is client wants to make multiple requests to the server. Okay, but here what happens is when R1 is executed or fired, okay, so R2 cannot be executed by the client until unless we get a response from we get a response of R1 from the server. Okay. Once we get the response of R1, then only R2 is fired. Okay. Okay. So in one particular TCP connection, the requests are sequential in nature. That is, they happen one after the other. I mean, we can make in REST also we can make a parallel request with multiple TCP connections. Okay, with multiple TCP connections, but within one TCP connection, the requests are sequential. Okay, the requests are sequential. Where else in gRPC, let's see, 2.2, right? As it uses 2.2, okay. So definitely between the client and server hosts the RPCs, okay, which the client wants to call. Okay. Now again, the same TCP connection is made between the client and server. Okay. But within the same TCP connection, within the same connection, okay, we can make multiple RCP calls parallel. Okay, it happens on HTTP itself. Okay, but they can be made parallel. So this is what advantage or benefits it provides, right? HTTP 2.2, which is called multiplexing basically. So within the same connection, we can make multiple requests, okay, which can happen in parallel. Okay, so this is the advantage. This makes gRPC faster as well as compared to REST, which generally runs on HTTP 1.1. Okay. Now, let's come to streaming modes. Okay, so I've already explained this. Like, so here, as I said, there are four streaming modes, right? So one is Unary, which is like the REST API only. So there's client and server, nothing new, right? The client makes a request, and in return we get a response from the server. Okay. Now let's see the server streaming. So what happens is the client makes one request. Okay, the client makes one request to the server, and the server responds with and the server returns multiple responses basically. Okay, multiple responses. So server is streaming the data from a server is streaming the data to the client basically by sending multiple responses. For example, client uh, okay, makes a request with some customer ID. Now against that customer ID there's a lot of data, so the server is streaming the customer data to the client, back to the client. Okay. Okay, so and hence this is called server streaming. We'll also see example through the code. Okay, then comes the client streaming. Okay, so in this particular setup, client sends multiple requests to the server. Okay, client makes multiple requests, and then it sends an indicator that, okay, I'm done sending my requests. Now you send me a response. So what happens is a server waits for all the requests to be completed. Once it gets the indicator, right? Once it gets the indicator that the requests are done, it sends one combined response, okay, back to the client. Okay, back to the client. Okay, this is what it is called, client streaming. And then the last one is bidirectional streaming, wherein when the client can send multiple requests, and the server can send multiple response, like it's asynchronous in nature, completely asynchronous in nature. Okay, like the chat application, right? The client and the server, right? The two users can send messages like asynchronously. Okay, so this is what is called, it's an example of bidirectional streaming. Okay. Okay, so both these client and bidirectional streaming, they are asynchronous in nature. Okay, I mean the client don't wait. Okay, the client don't wait for the response from the server basically. Okay, so these are the streaming modes. Now we will see a code. Okay, so let me show an example. So let's say we have this proto file. So in gRPC, right, as I said, it uses protobuf. So for this we have to define a proto file. Okay, so here we have a message hello request which the client will send, okay, in the call, in the network call, in the API call. Okay, so just you can consider in REST API, you can consider body, right? We send body, it's same. Okay, so it's same in the sense it is equivalent. Okay, so here we have a message, okay, hello request, which the client is going to send, okay, in the API call. Okay, sorry. And this is the reply, hello reply. Basically it contains the message and the sequence number, okay, which will be sent from the server to the client. Okay, now there's another section called service, wherein we define or we declare basically the RPCs. Okay, so here we have four RPCs. representing the four streaming modes. So okay, so first one is the unary mode, wherein the client will make a single request, which is hello request, to the server, and the server will respond with one single hello reply, okay, which is called unary. Now server streaming, the client will send one request to the server, okay, and the server will respond with multiple hello reply messages, which is, that is why it is stream, multiple responses it is going to send, that is why it is stream here. Okay, in client streaming, so the client is going to send multiple requests to the server, and the server will make one combined response, okay, with hello reply. That is why there's no stream here. Sorry. And in bidirectional streaming, the client will can make multiple requests to the server, and the server can respond with multiple responses, okay, and all this will happen asynchronously. Okay, that is why there is stream on both the sides, for the client and the server. Okay, so these are the declaration of the RPC. Okay, now what happens is when we compile the application, so as I said, stubs are generated in case of Protobuf. So let's quickly see. So here, hello request and hello response DTOs, as I said, right? As they are generated automatically. Okay, okay. So here we have the getters basically. So first of all, there's this name field. Okay, there's this name field. Okay, and then we have a getter which is generated here. Okay, this getter for the name. Okay, what else is generated? Let's quickly see. So hello request and reply we are seeing, right? Auto generated DTOs, getters, and builders as well. So for example, now the client wants to send a request, right? Send a request to the server. So the stub also generates a builder basically, okay, to build the hello request, to build the hello request object. Okay, so if you see here, we have builder as well. Okay, so here builder is also generated here, through which we can build the request, okay, and the response as well. Okay, so yeah, and then we have serialize and deserialize methods as well. So to serialize this hello request, right, into protobuf format, or the binary format basically, to serialize, and to like when this deserialize comes into picture, when the server returns a response, right, hello reply response, okay, to deserialize from protobuf to the hello reply object basically. So serialize and deserialize methods are also generated in this particular hello request and response. If you see here, yeah, so there are methods, definitely there are methods. Sorry, I had to put on the charger, the battery was low. Okay, so serialize and deserialize methods are also generated in these particular stubs. Okay, then comes this greeter gRPC. Okay, so let's see what is there, what do we have. Okay, uh yeah, so let me quickly, so this is also another generated class. Okay, so here we have so it also generates a abstract class basically. Okay, so abstract class which contains the declaration of all the RPC calls. Okay, so I won't go into much details here. So if you see here, uh, what is the name, so this is abstract class, okay, also generated, which will have basically the four RPC method declaration. Okay, and there are stubs also generated. Okay, for example, blocking stub and async stub. Okay, so these are used by the client to make the RPC calls. Okay, so blocking stub. The modes, right, the unary and the server streaming, so they are called through the blocking stub. They are blocking in the sense they are synchronous in nature, wherein the client has to wait. But this particular stub, like the client streaming and the bidirectional streaming, right, the client uses this stub, okay, and this is asynchronous in nature. The client does not wait for the responses from the server. Okay, so now let's go and see some demo. Okay, so here what I'm going to do is, first of all, so the server, right, the server and the client both are in the same, for demo purpose, both are in the same code base. Okay, So first I'm going to run the server. So let me also show you the server code here. So here the simple server code. Okay, it is implementing the generated abstract class, right? It is implementing that particular, extending basically the abstract class which is generated by the proto compiler. Okay, and here we are implementing the RPC calls. Okay, so here first of all is Unary, as I said, wherein we are getting one request and we are we are returning one response. Okay, so it's simple, like we are just building the reply, and through on next we are sending this we are returning the response through on next to the client. Okay, and on completed is the indicator to the client that the responses are completed from the server side, from the server end. Okay, similarly we'll see one by one. Okay, so first of all let me run this particular greater server. Okay, it is compiling. Okay, so server is started on port 50,051. Okay, now let me run. Okay, before that, let me go to the client. So here's the client. So let me quickly walk through. So here what we are doing is we are creating a channel. Okay, so where in channel it creates a TCP connection between the client and the server. Uh, and here see we are also creating the stubs. Okay, which are generated, which are auto generated, right, through the proto compiler, as I've already explained. So blocking stub and async stub we are creating. So blocking for Unary and server streaming, async stuff for client streaming and bidirectional streaming. So if you see here, so this is a Unary call. So let me first comment all these ones. Okay, we will demo one by one. We'll see the demo one by one. Uh, okay. So let me, or else let me run all the modes, and we'll see the output. Okay, we'll see the output of all these modes. Okay. So here, uh, yeah. So here we are calling the Unary RPC, right, through the blocking stub. Okay, so we are passing the request, hello request, right? We are building the request to this particular say hello RPC, Unary RPC, right? And through this Unary response, we are calling get message. This is blocking. Basically, this will wait for the server to respond. Okay, okay. So we will see. Let me run now. Let me run now. Uh, So if you see, we have got the response from the server. Okay, this is a response from the server for. So we sent one request, and the server responded with one response. Okay, so let's see the server streaming. So what is happening here is blocking stub again we are calling this grid many, and we are passing only one request to the server. Okay, only one request. And here, as I said, in server streaming, what happens? The client sends one request to the server, and the server responds with multiple responses. So if you see here, r dot get message, right? R dot get message. So this is basically we are iterating through the functional programming. Okay, so r dot get message. So server will respond with multiple responses. So here, if you see, right, so here we have got, based on the one request, we got multiple responses from the server. Okay, so we had sent only one request, right? Only one request we had sent to the server. Okay, then comes the client streaming. Okay, here let's quickly see. So what we are doing here is, let me come here. Okay, so the client will make multiple requests to the server, right? So here it is sending multiple requests to the server, like Alice, Bob, Charlie, right? And it is also sending indicator to the server that okay, I'm done sending the requests. Okay, I've sent you three requests, I'm done. Now return me the responses. Okay, so now what happens here is, okay, so now what happens here is, so on next, through on next, we will receive the response from the server. Okay, so here if you see client stream response, if you see here, So we have got one particular response from the combined response from the server. So hello to everyone, Alice, Bob, and Charlie. So through on next, we have got this, we have got the response basically. And on completed, again, this is an indicator from the server to client that I'm done sending the response. So if you see here, client streaming completed. Okay, client streaming completed. Okay, so uh, this is what is the client streaming. Okay, now let's go ahead and see what is bidirectional streaming. Okay, so here, yeah. So here, if you see, we'll also see on the server side what is happening. So if you see, let's go to the server side as well for the client streaming. Let's see what is happening over there. So here, in the client streaming, right? So yeah, so in the client streaming, what is happening is through on next, right? The server is receiving the request, basically receiving the request one by one. I mean, it's parallel definitely. And what it is doing is it is appending, it is basically collecting all the requests. Okay, through, for just, it's just an example, it is collecting. So we had sent three requests, right? Alice, Bob, and Charlie. So on next will be called three times. So it is appending the names, basically Alice, Bob, and Charlie. It is appending through comma separated. Okay, and what is happening is in the on next, right? It is getting the request from the client. Okay, one by one, I mean multiple requests from the client. Okay, it is appending those requests. Okay, it is collecting basically those requests into the names. And when on completed, right, when it gets the indicator from the client that it is done sending the request, it will generate one combined response. Okay, it will generate one combined response, and it will send through on next, it will send that particular combined response. If you see names, it has all the names. It will send that particular combined response through on next, and then it will send the indicator that it is completed, it is done sending the response. Okay, so this was the client side streaming, and we have also seen, right, in, now let's see the bidirectional streaming from client on client's behalf. So what it is doing is it is sending multiple requests, right? So here it is sending multiple requests through these three. It is sending three requests basically in parallel. Okay, the names are Ajinkya, Dev, team, and it is then sending the indicator that it is done sending the request. But as soon as server receives the request, right? Now let's see the bidirectional streaming on next, right? As soon as it receives the request, it also sends the response in the same, within the same. So as we saw in the client streaming, right, it was collecting it was collecting basically, it was collecting the request here, and it was sending one particular one combined response. But here in this bidirectional streaming, in on next, as soon as it receives the request, it is sending the response. Okay, on next, through on next basically. Okay, so here, so if you see here, so for example, the client sends one request, the server can return the response. It will immediately return the response for this particular request only. Okay, okay, so it is sending three requests, and it is getting three response. And as you know, right, through on next, we are fetching the response from the server. Okay, so if you see here, right, let's quickly see now. So yeah, so chat response, right? So reply to Ajinkya, reply to Dev, and reply to, so um, this is what server is this is what server is sending. Okay, so this is it. This is the code demo. Now, when to use gRPCs, right? So it's generally suitable for internal microservices, for internal communication, low latency calls, or real time streaming. Okay, so it is not great for public browser APIs because it does not have a very good support, right, on the browser side. And that is why for external APIs, REST APIs are still the best. Okay, yes, and gRPCs generally can be used for internal communication, for internal microservices, or real time streaming, as I said. Okay, so this is it. I hope you've got. Thanks for watching. Please subscribe to the channel, like the video, and also follow me on LinkedIn. Thank you so much.